I mean, I was not expecting that much people on a Sunday afternoon with such a shitty weather outside, but I mean, probably how much of you are really interested in the talk, or just sitting here because it's warmer inside, or drinking beer? That's a good reason. I mean, you have my vote on that. I mean, yeah, that's a good reason. So yeah, let's talk a bit about the CentOS infrastructure and the joy of running on community-donated hardware. I will explain why I choose that topic. So just a quick survey. Who is using already CentOS here in the room? Okay, job done. So who is more sysadmin and developer? Sysadmin first. Cool. And developers, the rest? Okay, cool. So first thing, who am I? That's a good question. I'm a local guy. I'm a Belgian guy. You saw that with a picture of a Belgian beer anyway. So that was easy to guess. That also explains why I love Belgian beer, but I have also that strange accent when I try to speak English. So, well, don't beer. I'm a sysadmin by choice, meaning that I really enjoy what I do. I'm not a developer at all. I had no coding experience, even if those days it turns to be infrastructure as a service and infrastructure by code. So we have two. I'm a CentOS user for a long time, I would say even abuser, just to due to the fact that I've installed and reinstalled quite a bunch of machines running CentOS, and I'm also a project member. So we'll cover a little bit of history. So you probably saw the nice shirt, the nice 10-year-old shirt that we have for the project. If you didn't get your shirt already, come to the K building. We have a booth, and we have a bunch. I mean, I really need to take care to get rid of all the t-shirts, because otherwise I will take those back home, and I don't want that, or my wife will kill me. So please feel free to ask a t-shirt at the booth. They are free. We'll cover the infrastructure overview, and also I think that we have people from other distribution. I wanted the talk to turn into a discussion with other people from distribution. I know that we have some Fedora guys there. I think there was supposed to be a guy from OpenSUSE as well. Is there? Fine. And Debian? No? Okay, cool. So at the end of the talk, let's discuss about, for example, the problem that we probably all have in common and how we try to solve it. We can learn from each other. So yeah, once upon a time, CentOS org started in 2003, well, for the domain creation, but historically, the real infrastructure started in 2004 when we had the first release of the CentOS project. Of course, at the time, if you remember, I don't know how much people were using CentOS 3.3, which was the first release ever. 1, 2 guys. Yeah, obviously me, I was there as well. So that was just a bunch of people doing that on their spare time for academic purposes only. It was just for fun. Let's try to understand how to rebuild source RPM in a correct way and put all that together into a distribution that is, well, a real rebuild. So that was, well, some machine just being in a basement or in the garage, whatever, just being used to rebuild a bunch of source RPM. And yeah, I think that at that time we had something like 5 donated machines, so companies interested in supporting us. And those 5 machines were just doing all roll at the same time. I remember it was a nightmare because one of the machines sitting in the US was at the same time the web server, the forum server, the master server for Mirror. Well, all the things you don't want on the same server, believe me, especially when it starts to become successful. So yeah. So how did we manage that 10 years ago? Wow. 10 years ago, configuration management was not the big thing on the new kids on the block. Everybody was searching for solution, and it was mainly a bunch of local scripts that were just used to manage those machines when it started to grow, and I will cover that later, the current infrastructure that we have. And yes, it was mainly maximum 10 people working on the CentOS project at a time, and I think that we just now reached 11. Wow. Interesting. So we were just doing that on our free time, meaning that we had day jobs. And we didn't want to spend too much time on things that could be automated. So that's how we started to invest time into automation. And yeah, we started to use Puppet since almost the beginning. The first version I was using myself inside of the CentOS project was Puppet 0.23. I don't know who has used Puppet 2.23, 0.23 here. Not that much. I mean, just for the history, in 2007, in the CentOS dev room, we had Luke Kennis just trying to explain people that Puppet Labs was the way to go. Well, just compare the situation of Puppet Labs those days. So the current infrastructure is that obviously we are eating on our dog food. So we have a mix of CentOS 5, yes, still in production, but still supported. That's a pros and cons of an enterprise distribution. We still have 5 CentOS 5 nodes running critical, mission-critical application for you users. 6, and we started to roll 7 in the current infrastructure. So the reason why, well, it's a slow migration because we need to remotely reinstall all those machines. We run exclusively on donated machine, and we don't have always full control of the machine. So we have to reinstall the machines and, yeah, basically to just get rid of the previous version. We have machines at the moment still being used, and they are the same machines that were donated to the project 10 years ago. Yeah, we still have machine running Pentium 4 with 1 gig of RAM. That's what we have at the moment. Not everywhere. So we have a mix, of course, of old and new machines. But we still have to take care of those old machines. And before the cloud was the new kid on the block and was really the hype and the buzzword, we had to consider for the CentOS infrastructure everything as being ephemeral, because we accepted the donated machines without any SLA, without any guarantee. We have nothing in the same data center. I mean, I think that we have one location where we have 2 machines in the same data center. So not possible to do a cluster with a machine sitting in Malaysia and the other one in Brazil, which is the situation that we have now. So that was an interesting challenge to try to solve. So as I said, there was a need to automate as much as possible, including installation of the operating system, obviously, but also configure those machines when they were running. So yeah, we migrate multiple times from Puppet to Puppet, and actually we migrate everything to Puppet 3.6 something. Well, we'll need to upgrade as well, but at the moment, that means that we are running Puppet Master D for CentOS on CentOS 6, managing the CentOS 6 and 7 node with Puppet 3.6, and the Puppet, still Puppet Agent 2.7 on CentOS 5 node. Do you know why we can't migrate to Puppet 3 on CentOS 5? Sorry? What, Python? For Ruby, yes, that's exactly the point. So the version that you need to run Puppet 3 something is higher than the one in the distribution, meaning that that's also a challenge when you want to run an enterprise distribution. Sometimes the tools that you use don't care too much about that. So, well, you have to jungle with all those things. But at the moment, it's still working. Puppet Master D 3 something can compile a catalog and can apply that on well, the agent can apply that without any problem. So the thing we've done in the past was, well, Puppet 0.23 was quite limited. So we decided to use something else, obviously. And at the time, it was a bunch of things just in the same. So we used Subversion at the time, which migrated to Git now. But we wanted to use something more sexy on top of. So we wanted to separate basically all the modules, the Puppet modules, from all the data, all the variables that were specific to group of nodes or just nodes. So you have multiple solutions to do that. One of the solutions is to use Foreman. We try to use Foreman both as a Puppet dashboard for the reporting feature and also as an external classifier. So we put all the things into Foreman. All the group are there, the config group, the dependencies, everything is there, so it's really easy. And Foreman is also a good API that you can use to interact. I will not cover that in detail because it's not a Foreman pitch, but it's really a good product to use. For the monitoring, we tested a bunch of solutions in the past, and 2 of us in the CentOS infrastructure team were using Zabbix for our daily job. So we knew Zabbix quite well, and it works perfectly fine for this kind of CentOS infrastructure that we have at the moment. So basically, we have agent on all nodes, and we have some external check. So basic thing that you do. The only thing that it was really interesting to have is Zabbix proxies. Because if, for example, you have your monitoring server that is sitting somewhere in the US, and that you have to monitor some machines in Australia, you can have big latencies. So the more proxies you can have to just unload a massive server for monitoring task, the better it is. DNS, nothing fancy, nothing special. Well, at first sight, bind is obviously what we use because it's in the distro, it's stable, secure, everything. But we add a special need to delegate something to other DNS server. Why? We use Power DNS for that, which is not in the distribution, but it's a package really easy to compile. It's available in the EPEL repository as well. So why did we decide to use Power DNS? The interesting problem that we have within CentOS is that when we have millions of machines coming to the mirror network at the same time, what can we do? Well, we try to say that we want you to be redirected to the nearest mirror, meaning one of the mirror in your country, if you have one, if not a nearby country, and if not possible, at least a mirror in the continent. If you have no mirror in the continent, that basically means that you don't exist, so we don't care. So for that, we needed a specific plugin, and we decided to use GeoIP. So bind at the time was not possible. It was not possible to have some kind of access control list and redirection and specific. You can do that with Vue in bind if you know bind, but you had to do everything from scratch. So we decided just to use Power DNS for that, and we just redirected. We have two kinds of requests. So I will speak about the msync node, what we call internally the msync node, which are basically the mirror machines, but also the rsync target that we use so that external people can rsync the complete CentOS 3 from when they want to become an external public mirror. Same thing for them. We just redirected them to the nearest mirror, and we don't want, for example, someone from America sitting on a 10 gigabits link being connected to, for example, a machine in Malaysia connected at 10 megabits, which is the case. We have some machines, for example, connected sometimes at 10 megabits. At the moment, Power DNS is really simple. I mean, we like the KISS principle, keep it stupid and simple. The Power DNS thing is just a custom backend. At the moment, it runs on very old machines, but is able to handle something like 400 requests per second, which is nothing. I mean, from a DNS point of view, that's really nothing. At the same time, it's interesting because normally, as an end user, we are not supposed to even do that kind of query. I will cover that when I will speak about the mirrorless thing, which is quite different. When you run YAM update, you see that you have fastest mirror and you are directed to a list of external mirror and not one from mirror.centos.org. So yes, obviously, like every project, every distribution, we have other nodes like covering web services, the forums, bug tracker, mailing list, torrent tracker, and CEDAR. So yeah, that's really basic thing. So let's cover, for example, one of the role. That's probably one crucial role, I mean, for you and user. It's the msync role. We have at the moment 60 donated machines running CentOS, and that their main role is only to fetch new releases, security updates, and push them as fast as possible to the other node. So what we do is that from the build system point of view, we have two master nodes that are in separate data center that we know for sure we can trust. We don't want those machines to disappear. Pushing to, let's call those ring 0 and ring 1, some machine connected at decent speed. We push to those machines, and directly after, we just push to level 2, ring 2 machines. When it's done, it's available to, at the moment, we have more than 580 external mirror fetching all the updates from us. So that's meaning that from a statistic, when we have a new release, when we do an aggregation on all the statistics from those mirror, from the mirror that we control, not the one that you are fetching updates from, we are pushing during several hours at more than 4 gigabits per second. So all that on donated machines. The current status is that we have a lot of machines in the US. CentOS at the beginning was really strong and has a strong presence in the US, meaning that a lot of people from hosting industry and companies were interested to have a local mirror there and said, well, we have thousands of servers, so we can give you one access. So please reinstall it, do whatever you want with it. We have a few in Europe. We could do with better machines and more machines. And the problem is more in Africa or in Asia. That's really where we have problems. I'm guessing that it's the same thing for other distribution as well, because yeah, lack of resource. We have only one machine, for example, for Africa, which is in South Africa. So that's really difficult to solve at the moment. And yeah, sometimes I said that even in 2015, we have machine connected only at 10 megabits per second, which is, well, if you consider for probably the connection that you have at home, you have better connectivity than that, and it's a server in a data center. So why do we want to keep that? I want your opinion. Why, for example, CentOS still interested in machine connected at 10 megabits per second? What would be the good reason for that? Yeah, good point. Thank you. So sometimes you have countries that are peering problems. I mean, they have really international connectivity that are really thin. So it takes more time, for example, to push update to a machine in Malaysia connected at 10 megabits. But internally in the country, they have better connectivity, meaning that, yeah, it's slower to get updates to that machine first, but when it's there, it's faster for all the consumers there. We don't care about the fact that they just they don't use machine externally, they use that machine because they are geo-IP redirected to that machine. So that's better for the user as well. So what we do is, I told you about the msync role, so the mirror.centos.org role. Normally when you install a machine and you run YAM updates, you are not supposed to hit that mirror.centos.org, let's call it CDN, because we have more than 580 external mirror at the moment. So you're supposed to hit one of the country you are in, from which you are using the YAM update command from. So what we have is that we have a mirror status machine that's check in loop. It's just do that in loop. It verify those 500 mirror in the loop times. It just verify every repository, every release, and every architecture. It even check the ISO of the checksum of the ISO file, so that when, for example, you want to download, you are sure that it's validated. So if you have a look from time to time on centos.org/download, you will see that every 5 minutes it's refreshed with validated mirror. Machine appear, other disappear. So it's done in loop. For the people interested in knowing how it works, we just generate a list of validated mirror for a specific repository. So if, for example, you use that simple curl request, that's exactly what YAM is doing. It's just checking, say, mirror list, tell me give me a list of mirror that are validated for my actual release, and that's it in your country. And we use the same process when you want to download an ISO image. If you want to download the ISO image from the website, it will just use the ISO redirect.centos.org web service, which just gives you back a list of validated mirror in your country or the nearby country. Yes, question?
Do you include the country code in the URL here?
What? No, that's just for example. I mean, if for debugging purposes in the script we are using in the backend, I'm forcing that to be, well, B because I'm Belgian.
So you can override it?
Not on by YAM, no. YAM will use the maxmine, well, the mirrorless server will use maxmine to guess from your IP, supposing that it's good, because sometimes we had user complaining that, hey, maxmine thinks that I'm in Ireland, but in fact I'm in the UK. So sometimes, well, we have no direct, we can't tell maxmine that there's something wrong, they have to update the database, but, or you can, as a user, for example. but it's dynamically done. So back to the donated machine challenge. As I said, well, all the machines that we are using are donated machines, but well, in a perfect world, that would be fine. Except that after 10 years, I can tell you that we have sometimes trouble. In the sense that we have lost, for example, I don't even count the number of machines that we have lost over the 10 years. And for various reasons. Sometimes, well, there is an hardware issue that can be solved. That's not a problem. But sometimes it's something else, and I will cover that in the next slide. So, for example, we had to, we've lost, even just for 2014, we've lost several msync nodes, so mirror.centos.org nodes. We had to migrate, for example, the main wiki 3 times during, I mean, in the last 2 months, I had to migrate the wiki services 3 times. Because, yeah, it's not possible to schedule in advance what happened on those donated machines. Well, if it's a msync node, well, we have plenty of. When it's the main glue record that you have to migrate, well, you hope the best, and you hope that those people will tell you in advance, otherwise you are screwed. And that's one of the risks we have sometimes. So we try to, obviously, to migrate that to company, to machine that we trust for a long time, that we know that for sure that they will stay. Same thing for the services that I had to migrate just in 2014. The mailing list, the bug tracker, planet.centos.org, the mirror status node to the crawler that just verify all the mirror I had to migrate. So, well, you have to use automation, otherwise, well, it's game over. So, back to the change of donated machines. Sometimes they don't even tell you that they don't want to sponsor you anymore. So you had a contact, for example, back in 2005 from Mr. B at company C, say, well, I really like what you do. I want to give you an access to a machine sitting in my data center. Fine. But what appeared to that company over the years? Sometimes bankruptcy. And you just discovered that when Zabbix suddenly said, well, your machine doesn't seem to be responding anymore. And you try to contact the guy or the POC, the point of contact you had, and nobody's answering. The email bounces back. Or worse, you see that the domain doesn't exist anymore. And then start the trouble. Other thing that we had also is that I said, Mr. B from company C told you that, well, you could use a machine, no problem. But company C has been acquired by company B, and sometime by company A. But company A doesn't care about open source. So suddenly, they said, we don't want to sponsor you anymore. I mean, well, it's not the business model, so we don't want you to use the bandwidth. So bye-bye. In the worst case, they don't even, in the best case, they send you a mail. In the worst case, you just discover that through the monitoring system, which is also bad. Somewhere in between, we had some interesting situation when we discovered that, for example, the company was not existing anymore, was acquired by another one, but we still have access to the machine, it still runs. We have no contact, nothing, no details. When we try to reach, they said, no, your machine doesn't run in our data center, but it still does. So, you know, it's then a chicken and egg problem. What you can do? Can you still use it or not? I mean, So, and yeah, sometimes they just completely disappear and you don't know. So when, for example, a company said, we want to help you, we want to provide you access to machine, the first thing we do is that, yeah, we say thank you, obviously. And the first question is, which kind of distribution do you want on that? I mean, do you really expect me to answer Windows? I mean, let's be honest. So yeah, obviously, let's give you access to the machine with SSH, or just send you just send me my public key that I can use to inject. But what we do is every time we just reinstall a machine. I mean, do you trust someone giving you access to a machine? Believe me, I've seen strange things in my life. Like hosting companies, they said, well, you have a dedicated server, The first thing you do when you log in, you say, well, I will probably do a complete audit on the machines, and you see that they inject their own keys directly into root authorized key. Come on. No, please. Or they are using different kernel, or they override base package. I mean, that's their choice. No problem. I don't want, I will not mention OVH. Oh, I did, sorry. With the fact that, for example, when you say, well, give me a CentOS machine, it's not. They are just using a completely different kernel. They disable everything, like SLNX is disabled just because they have patching GRSec into the kernel. I don't want to support that. I don't have time to just spend, well, hours just to do an audit. It's ephemeral. It's a cloud. Even if it's a bare metal, it's a cloud parting. Just reinstall a machine that's faster, right? We have Kickstart. It's there for a reason. So we just reinstall from scratch, and then, well, Puppet come to the rescue and configure what I want on the machine. So, but we just start always small. Because, yeah, we have companies supporting us for now 10 years. They're still there. Can we trust those people? Yes. Can you trust a random guy saying, I want to give you a machine in my data center somewhere in a strange location? Probably, but you can't know for sure. So what we do is that it's about trust relationship. You want to establish a trust on long term that is to be proven. So what we do is that we start with sometimes just the msync role. Well, that seems a little bit strange that I start with non-crucial role, while at the same time I say that those machines are mirror.centos.org. It's true, but we don't run anything sensitive on the machine. Anyway, that's just CentOS mirror. And all packages are GPG signed, so even if they wanted to do something strange, from a YUM client point of view, you would see the difference anyway. So, and if the machine just disappears, it's just a matter of just removing from the DNS the PDS backend, and nobody noticed anyway that the machine just disappeared. So we start from that level. Another good thing to do is we usually test the response time. Because, yeah, sometimes you would be surprised that they have a sophisticated mechanism, but you ask them something, and because you are open source, obviously you are not a paying customer. I mean, I don't mind. It's a rule. But it took 3 or 4 weeks to get an answer. On a machine that you need to rely on, no way. So even if you have nothing critical, even if you have no problem, just test the support response time and whatever. That's how we can, well, quantify the quality of the support. And then with the time, we know that we can trust because we can trust them, and then put more crucial role. I mentioned the fact that, for example, we had to migrate the main ns1.centos.org record, the glue record on the machines. When we decided to move elsewhere, we need, of course, to not just, well, blend in a random way, say, like, whoa, let's take that one because I like location. No. It was from a provider who showed that they were there, they were supporting us, and that's the location where we have 2 machines in the same data center. We can move the IP back and forth on the 2 machines. So yes, we can use those. We have also other resources, sometimes own the machine that we own, like we just recently announced for the people in the special interest group that we have a small dev cloud. We call it dev cloud. So we have 4 physical nodes running in the DC in London with quite a bunch of memory and CPU, and we are using just local SATA disk because, well, that storage is always an issue, and we're just aggregating the local SATA disk with Gluster and present the whole thing as a single storage solution for the physical node. So the physical node are at the same time hypervisor, cloud, and storage provider. So, but it's for testing purpose, so that doesn't mind. And we use OpenNebula as a simple solution for that. So what's the future within the CentOS infrastructure? We started a thread on the CentOS dev list. I don't know if you have read it, if you have read it, but there is a way for centralized authentication more and more. When the team was just 5 of us, Puppet was clever enough just to deploy the SSH key where it was needed. There was no need. There was not a need for central authentication, but we are just opening up the whole thing. I don't know if you were there yesterday, but Thomas from CERN spoke about the cbs.centos.org, which is mainly community-built system. We have a bunch of machines just being there in the Koji system. But Koji relies on also centralized authentication, and we needed to generate a bunch of X509 certificates. So we need a common tool to do that for us. We can't rely on Puppet for that anymore. It will not scale. Another need is self-service portal, meaning that people would be able to, I want to contribute to the CentOS project. Let me just create an account, and then I will be given rights on several things. 15 minutes, yeah, no problem. That will be finished. Thanks. So last but not least, faster updates on Mirror. We had, and I say we had, you included, we had a strange problem this week. I mean, Ghost, anyone? glibc updates? Okay, so people not aware of what I'm talking about can just go away anyway, or not, you are not really sysadmins. So the interesting problem there is that from a CentOS point of view, the update was built quickly. In less than 15 minutes, it was on all the mirror.centos.org node. But then, 5 hours after that, people were still complaining, update is still not there. Why? The problem is that external mirror are supposed to sync from us, but we don't control those mirrors. So we don't know when they want to update or not, right? So we have a problem in the sense that we are thinking about, I mean, if you have an idea about that, I'm all open, I mean, for that. We're thinking about using something more clever like a CDN or a message bus that external mirror can we just publish and people can just subscribe and take action or whatever, but we still don't know. I started to speak with Pierre-Yves with that because in Mirror Manager, they are just rewriting. Do you know Mirror Manager from Fedora? I guess yes. Question? Yeah? You said yes, or you had a question or an advice? Okay, I said, I was thinking you had a solution. I said, yeah, you are the guy. So we are thinking about that. So I would be interested in, I know that we have some people from OpenSUSE and Debian. So how do you solve that problem at the moment? Yes?
For OpenSUSE, we use mirror brain,
Yes?
which is kind of which is taking care of notifying which mirror is up to date and which one is not.
Yeah.
We always redirect the download to the mirror which are up to date. So people don't configure to a specific mirror, they always configure to the mirror brain,
Yep.
which is taking care of not sending people to not up to date mirror.
Okay, so suggestion is to use Mirror Brain. And yes, I just had a look at Mirror Brain, but it's basically exactly what we are doing at the moment and also what Mirror Manager does. So, I mean, with more than 580 mirrors to just verify a crawler process, we need to verify 3 distribution, 2 architecture per distribution, and base, OS, update, extra, multiple repository in the same distribution. The crawler process takes more than 4 hours to do that and to validate. So I was thinking about something like an emergency repository where we could just drop and by default just point people to that repository.
One question for OpenSUSE, how often is the crawler running? I don't know. Because if you do it like once or twice a day, most of the time you're going to have up-to-date mirrors. But in the case of emergency updates or GDC,
Yeah.
I mean, twice a day is already 12 hours, and you want to have the updates pretty much really fast after that. For the emergency, like an update like GDC, Shellshock, and stuff like that, we have our own infrastructure, which we know is always up to date. So in the worst case, Mirror Brain will redirect to our own infrastructure. So you cut down everybody else and just point to your master mirrors. Yeah, that's what will happen until the mirror catch up.
That's one of the solutions we have. Because we control the mirror list, we can say, well, just return mirror.centos.org and we are fine because we are sure that we are up to date. We control this machine, we monitor this machine. But when then you have millions of machines hitting the same 60 machines at the same time, well, it's a good reason to, yeah.
So, I mean, forgive me, perhaps I don't know much about YUM as Debian format, but with, can you not put both mirrors in there in a priority order, and then if that update is on the federated mirrors, then it can pull it from there. Otherwise, to get it out quicker, you have it from security.centos.org.
Yeah, so that's one of the solutions. So it's a mix of, let's try to validate up-to-date mirror, and in the meantime, just redirect to a specific repository or just the mirror.centos.org nodes. So yes, I mean, we wanted to do a live test, like just using, for example, putting all the updates to just mirror.centos.org. But basically, then we had a bunch of phone calls or machines just disappearing from the mirror network, because those companies said, you exceeded the quota that you were allocated this month. So that was even more trouble than a real solution. That's also, we don't control, well, those donated machines is really it's a challenge. It's good because the C in CentOS is community. So we still like, and we rely on those community machines, on donated machines. But we need something more robust from time to time. So, I mean, how the people from Debian are doing that? No solution probably.
The security.debian.org, which is run by the Debian system administrators on Debian owned hardware.
Okay.
And also some community owned hardware, I think, but run by Debian system administrators. And more recently, Debian's been playing with CDNs because obviously they are CDN providers willing to provide bandwidth to big project centers.
Okay.
How many machines do you have usually on the security inventory?
No tens, I think. I don't know.
Because we have been running into the same thing. I mean, what we shut down your manager, and after having instead of having the crawl that just crawl all the mirrors for all the updates, just having the crawlers, check, do you have the latest glibc, and if it's there, just re-add mirrors to the list of, to the pool of mirror available. But then one of the questions that we had was like, yeah, but if we announce, so if we also mirrors than the master mirrors, and we announce that there is security updates, everybody's going to run new updates, and everybody's getting to it, the master mirrors, which is also not the idea of security.
The difference in Debian is you can have multiple mirrors in your sources of lists. So you can hit your local mirror first if it's got otherwise.
That would be interesting to continue a discussion on. I was thinking about, for example, using some kind of sysadmin cross-distribution list on which we could share information, because it's all about, yeah, learning from each other. Because we are trying to solve the same problem that we all have at the moment. So that would be probably an interesting discussion to have all together. Why not? So yes, question, because yeah, it's question time. It's your question time. Yeah, the first one in the back. Yeah. Yeah. Sorry? How do we keep the infrastructure that we have? Do you mean from an inventory point of view? At the moment, we have, we store a maximum of information if possible in Foreman. But on the other hand, we still have an inventory that we just share with sensitive information like point of contact, email, telephone number if possible. So we do that on, in a Git encrypted repository. So it's easy. Everybody can have access from the sysadmin team at least. So that's what we use for tracking. And we also track when a machine, for example, was donated, disappeared, because sometimes you want to track if a company was acquired by another one. We had that funny story when we discovered that because of acquisition, we had two companies that were merged into one, and we had two machines in the same data center, but historically from different companies. So from that point of view, it was not, it was not a good idea to put the same role on this machine because they were just struggled by the same network connectivity anyway. So we just try to do a mix and match of, we track all that into separate files, but we don't have any specific tool to do that at the moment. So, other question? Yes?
So actually, it's actually two kind of questions. So the first one is,
Yeah, I mean, virtual machine can be really interesting, and we use virtualization when possible. But when I say that, for example, what do you do when you say migrate? You mean migrate in the same, well, on two physical machines in the same data center or on the same rack, which we don't have. I mean, well, then what's the benefit of using virtual machine? I mean, you just need to. At the moment, everything is puppetized, so whatever it is of bare metal or a physical machine or a virtual machine, it's just exactly the same way of migrating with, except if you say that you are just using virt v2v or whatever to just put completely the machine over. I prefer just Puppet doing the reinstallation. The machine is sometimes faster.
So you don't actually have any kind of use case on those machines, like developer or infrastructure developer would use?
There are a few.
Websites or like a Jenkins installation or whatever?
Yes, we have Jenkins, but then for the specific machine, we have obviously backups. But we don't have the crucial role at the moment is more the mirror content for outside. So, and we saw a big difference when we try, for example, to run that specific node in a virtual machine because of the kernel cache and the I/O to disk, because you want everything and more in cache if possible. Well, it didn't scale, so we decided to just use bare metal for those nodes. Anyway, it depends. Sometimes we receive a machine that with plenty of memory, and well, we have another mirror next to the one in the same data center or in the same country. We decide to use that one for specific smaller role, like the web server, for example, is one of those examples. And we have multiple virtual machine on the same physical host. Yes, we use, but not that much. Just because you have one machine there, one machine there. It's not like the on-premise data center thing that you can have, like on-premise cloud. We can't, because it's geo-dispersed everywhere around the world. That's one of the challenges we have at the moment also. I would like to have everything into one data center, another one for disaster recovery purposes, but it's not the case. Other question, or I think I'm out of time, no? Yes, I'm out of time, so thanks.